Okay, so from the previous videos, we have discussed what an array is, the purpose of an array, and how to declare an array, and how to access members of an array. So in the previous examples, we have mentioned that it is a good practice to always define, to use a macro to define the length of an array. So going back to our previous examples, we have we wanted to primarily compute for the average of an array grade, right? So this ends, um, we declare an array na grade with type float along with its length, which was defined with a value of 5, and then along with the other scalar variables like average and sum. So if you remember what a scalar variable is a variable with a single na value, right? So, and then um, we access, and then for each na members of the array, we will be assigning values to them, right? So we enter the scores in one line, right? So let's say we enter 5 grades, and those 5 grades will be saved in this each element in the array. So this first grades of 0. So this refers to the first element in the array, right? So this maps to this placeholder. This grades of 1 maps to this, grades of 2 maps to this, and so on, right? So, and later, we individually access the elements of the grades array, and the variable sum stores the cumulative total of the elements of the array. So um, these grades of 0 will have the value that is first entered by the user, right? So again, this topic refers to subscripting, okay? And then we compute for the average and print its results. So this is not really practical if we will enter a lot of grades, okay? And this line will be extremely long. And so what we can do is use loops to enter the value. So many programs contain for loops whose job is to perform some operation on every element in an array. So here are a few examples of typical operations on an array A of length n. So this one, so suppose we have an array A, okay, and then we will be use looping. So if we have a loop, so we start with an initial value na 0, and then we just loop through until we reach the maximum length of an array. Okay, so that means na if nag-exceed na dito, that means that there are no longer elements that we can access. And then this part is this this lines of code is what it does is clears a or assigns a 0 to each member of the array A. Okay, and then what about this one? So it reads data into A. So we look through the array na A, okay, and then until such time that we reach the maximum length, and then for each then we read data into, or we store data into each element of the array. And then last part is that we sum the element of A, and then we are getting the cumulative total, right? And saving each of the values of array na I and sum. Okay. So there are just warnings and then errors that we have to watch out for. So C doesn't require that subscript na bounds to be checked. So if a subscript goes out of range, then the program's behavior is undefined. So remember, an array always starts with 0. So elements are indexed from 0 to n minus 1 and not 1 to n. So for example, This illustrates a bizarre effect that can be caused by this common blunder, which we refer to as the off by one error. So, for example, we have an array A with a length 10 and a type integer, and the the count I is simply the counter in the loop that we have created. So we create a loop to loop through the elements of the array. So our condition, what we want to do here is that for each member of the array I, we will be setting or assigning its value to 0. And this will continue for as long as this condition is true. But our condition is that I is less than or equal to 10. Okay, so, but when I reaches 10, the program 0 stores into A of 10. But your A of 10 does not exist. Why? So this innocent na looking for statement causes an infinite loop. So bakit A of 10 does not exist? Because again, your A subscripting starts with 0 and ends with the last element is n minus 1. Okay? The subscript is n minus 1. So yung last na element can be accessed with A of 9. Right? So the A of 10 does not exist. So this will cause an infinite na loop. Okay, so again, let's keep things, let's have some more example. So imagine there are 5 students in class. So it's the same example that we have in the previous na videos. Okay, so we will be using loops to individually read the value entered and store to the address of the elements na access. So if you can see, here, so this is the expected na output. So you enter the grade for each na student. So each of these grades will be stored in array. So this first grade of student 1 will be stored in grades of 0, 85 will be stored in grades of 1, 97 in grades of 2, 16 on grades of 3, and 82 in grades of 4. So again, remember that our array start by 0. Otherwise, we will be committing the blunder that we have introduced, which is the off by 1 error. Okay, so we will be using a loop to individually read the value and store to the address of the element accessed. So we start with 0. So we start with 0 because our array starts with 0. And our condition is that our I should be less than n of n students, which is 5. Right? So we enter the grade of the student, and then we store it in its specific na position. All right. So thank you for the loop. So we don't have to define 5 lines to in order to store values to each of the elements. And then another is that we will be using a loop to individually access the value of each element of the array na grades. The sum then stores the cumulative na total of all the elements of the grade. So in the previous na for loop, we are assigning a value to each na element. And then here naman is we are accessing the values that we have entered previously. Okay, so let's say at this point I or 0, so it starts with 0. So the first grade is 57. So we store it in the sum, and the first value of the sum will be 57. And then the next stage of the loop, the I will now be equal to 1. So the 1 is less than the number of students, which is 5, which is the condition is still true. So we add this grade 85 to the previous na sum 57. So 57 and 85 is now 142. So that's the current value of sum. And then we loop through again. I is now equal to 2, and 2 is still less than 5. So it is still true. We access the grades of 2. Okay, so and the grades of 2 is 97. So the 97 will be added to the previous na sum 142. It's now 239. So the new value of sum is 239. And then we go back to the loop, and then I is now equal to 3, and 3 is still less than 5. So we continue. So sum plus or equal to grades of 3. So the grades of 3 is 16, and 16 is added to 239. The sum is now 255. Okay, and then it loops through again. I is now 4, and 4 is still less than 5. And so we access grades of 4, which is 82, and then add to the previous na sum, which is 255. And now our current sum is now 337. And then it loops through again. Your I is now 5. So 5 is not less than 5. So which means that it is false. So we are out of the loop. And then that final sum will be divided by the number of students in order to compute for the average. Okay.